All right, so this is a combination of the last 2 days, right? And the ands and the ors. That's the biggest thing you want to, that's the first thing you got to notice, okay? So is it one event and there's an or statement, or is it more than one event and it's an and statement? So this says the six-sided die is rolled. Find each probability, first decide if they are mutually exclusive or not. And we're talking about the sum, or the probability that the number rolled, not the probability of like the sum. But remember, if we had two, we'll talk about that box again. Like, you're going to want to know how to build that box specifically on your test. So make sure that we go back to it at some point. Remind me. Okay, this one is just one six-sided die is rolled. The probability that the number rolled is less than 3 or greater than 5. So first of all, it's an or statement. This means we're going to add. And if it's an or statement, then you have to check if it's mutually exclusive or not, right? So can something be less than 3 and also greater than 5? No. So they're mutually exclusive, which means we add the probability of the first. So the probability that it is less than 3 plus the probability that it is greater than 5. So how many numbers are less than 3? 2 out of the total amount of sides, which is 6. And how many numbers are bigger than 5? 1. So I'd get 3/6, which is 1/2. Then 2 says the probability of rolling a number greater than 4 or even. So again, it's an or. So now we see mutually exclusive or not. Can something be greater than 4 and also even? Yes, so this one's not mutually exclusive. So probability greater than 4 plus probability even minus the probability that it is greater than 4 and also even. So how many numbers are greater than 4? 2 of the 6. How many are even? 3 of the 6. How many are bigger than 4 and also even? 1, just 6, right? So this is 5 minus 1, that's 4/6, which is 2/3. Questions? Yeah.
Why do you subtract that?
Because if it can be both, you have to account for it being able to be both. So can it be greater than 4 and also even? Yes, because 6 is bigger than 4 and also even. If it can be both, you have to subtract the likelihood that that happens. All right, second slide. A card is randomly selected from a standard deck of 52 cards. Find the probability of the event. Number 3, these are all also or statements, right? 3 says selecting a 5 or a face card. Is it possible for it to be a 5 and a face card? No. So probability that it's a 5 would be 4 out of 52 plus the probability that it's a face card. How many face cards are there? 12 out of 52. So I get 16 out of 52. I could keep reducing this. 26, 4/13 is where it goes. Number 4, a face card or a diamond. Can it be a face card and a diamond? Yes, right? Yeah. So this time it's not mutually exclusive. So probability it's a face card, 12 out of 52. Plus probability it's a diamond, 13 out of 52. Minus the probability it's a face card that's a diamond. How many face cards in each suit? 3. Good. 3 out of 52. So 25 minus 3 is 22 out of 52. 11 out of 26. Number 5, an ace or a 9. Can it be both an ace and a 9? No. So probably it's an ace. There are 4 aces. Probably that it's a 9. There are 4 9s. So 8 out of 52. Which 2 out of 13. And the last one, a 10 or a diamond. Can it be both a 10 and a diamond? Yes. So probably it's a 10. There are 4 of those. A diamond, there are 13 of those. And a 10, that's a diamond, there is 1. So 17 minus 1 is 16 over 52, which is 4/13. Questions on any of them? So they were all or statements. We will obviously continue to review, like when we get into the review, which will start tomorrow, we'll bring back some of those and statements. As far as your test goes, I think it's 18 questions. I built it. It's done. 18 questions. There are some multiple choice with a calculator. I think it's 8. 8 multiple choice with a calculator. And then the rest are not multiple choice or with a calculator. So you'll get it in 2 parts. It is not really like this type of question is with a calculator. It is more like how big are the numbers in that specific question. Things like summation will definitely not be calculator like that for sure. I didn't give you summation as calculator because you could just use the button, okay? But the rest of it, like these are not big numbers. Plan on these being on the non-multiple choice part, which is non-calculator. But like things in which we were multiplying larger numbers together, those I gave you on the multiple choice part, which is calculator. Yeah. Yeah, is it 13? Yeah, okay, we're going to do it. So this one, and I don't know what yours each individually said, but this one specifically said a shipment of 10 microwave ovens contains 4 defective units. Vending company has ordered 4 of these units, and because each is identically packaged, the selection will be random. A, what's the probability that all 4 units are good? So you have to look at this as like, what does that mean in terms of an and or statement, right? If it's all good, that means we want the first one to be good and the second one to be good and the third one to be good and the fourth one to be good, right? So as they're taking off these units, would it be an independent or dependent event to go grab that second one? Like, are they taking a unit off the truck and putting it back? No. So it's off the truck, which means what's left in my sample space has been altered. Does that make sense? Which means it's dependent. So the very first time, so I'm saying, what's the probability that it's good? Times the probability that it's good, given the first one was already good. What's the probability that it's good, given that another good one was already taken? And then the last one, good, given another good one was already taken. So first, I know it started with 10 microwaves. There were 10 to start with. How many of them were good? In this case, there were 4 defectives. How many would have been good? 6. Now we assume we took off a good microwave. So how many good microwaves are left?
Wait, why 6 over 10?
Because there is 10 total microwaves, right? 4 were defective, which means 6 were good. Now let's assume that we took out the good one. How many good ones are left? 5. And if we took one out, how many total units are left? 9. Now we took another good one out. So how many are left? 4. How many total are left? 8. Now we took another good one out. How many are left? 3. And how many total? 7. And then when you simplify that, you get the 1/14.
I watched a video and it's the C with
The combination.
8, 5,
Yeah, you could do it that way. I think,
super fun.
yeah, I think this makes more sense. Yeah. Okay, let's go to B. You won't ever have to do it with the C. Let's say that way. Like, I'll never give you a test question in which you'd have to do it that way. B says, what's the probability that exactly 2 units are good? So this means I want the first one to be good, the second one to be good, but then the rest not good, right? So what's the probability I get 1 good one? The first one. 6 out of 10. Now assume I got a good one. What's the probability I'm going to get another good one? 5 out of 9. Now what's the probability I'm going to get a defective one because I don't want any more good ones? How many defective ones are in there? 4 out of how many are left? 8. Now assume I took a defective one out that time. How many more defective ones are left? 3. And how many left total? And then keep going, right? Because I'm taking all of them. What would be left? 2 and 6. And, wait, did it say you're taking 4? Ordered 4. Sorry, I'm stopping. I went too far. Stop at 4. And then you multiply those out. I would say not as complicated, but you do have to understand that something like both means both means an and statement. Okay, neither is also an and statement because it's just the reverse of it. Those kinds of things are important. All right.
I didn't do that because it said to use 8.5.
Oh, okay. Okay, C says, what's the probability at least 2 units are good? That means this, and this is where it gets tricky because, and you won't get this on your test, but it means that I can start with the first 2 being, but then the rest can be anything, if that makes sense. So if my first one was 6 out of 10, I want at least 2 good ones. Let's say the first one was good and the second one was good. The rest can literally be anything else. So the next one could be any of the 8 and the next one can be any of the 7. Does that make sense? Okay. Are you saying yeah just to say yeah? Okay. All right, good. All right. Yeah, because it's only 4. You're only pulling 4. Yep. All right. if you need a break from probability, here it is. This is called the binomial theorem, okay? You might miss the probability after. I'm a nerd, so I enjoy it. I get it, but I think it's kind of fun. What we're about to embark on can be tedious, but it is not difficult if you understand what you're doing, okay? This is a binomial expansion. So it's called the binomial theorem, but it is binomial expansion. What's a binomial? Two terms, okay? When we raise it to a power, we expand it. So x plus 2 squared. If I multiplied that out, I would expand it. X plus 2 to the third, I'd have to multiply it 3 terms. X plus 2 to the fourth, I'd have to multiply 4 terms. The good news is we are not doing that. We're going to learn that there is a pattern to doing that, okay? And then we are just simply multiplying a bunch of numbers together. So, for example, if I had x plus 5 and I multiplied x plus 5 times x plus 5 times x plus 5 times x plus 5 times x plus 5, and I combined all my like terms, I would end up with this as my result. If I did it to the 6th, I would end up with this as my result, okay? Notice there are a couple key features about both of these. One is that there are n plus 1 number of terms in my answer. So whatever my exponent is my n. If I am raising something to the 5th power, there will be 6 terms in my answer, n plus 1. If I am raising something to the 6th power, there will be 7 terms in my answer, always one more than the exponent, okay? That's the first thing to notice. The second thing to notice is that your variables have symmetric roles. So let's just, for example, look at the top one. Notice that this is x to the 5th and this is y to the 5th. And then I get x to the 4th and y to the 1st, and I get x to the 1st, y to the 4th. And I get x to the 3rd, y to the 2nd, and I get x to the 2nd, y to the 3rd. So they build up, okay, or build down. It doesn't matter how you look at it, but they are symmetric. Your ends are going to be symmetric, and then they will build in. If there's an even amount, so we've got 6 and 6, then we've got 5 and 1 and 1 and 5, and then you've got 4 and 2 and 2 and 4. The middle one, they will have the same amount, okay? So that's what happens if it's an even amount. Yep.
Why is there 15 and 20?
That's the next part. So, well, actually, that's the next part is the sum of the powers. I'll get to that. That's the coefficient one, okay? The sum of the powers add up to your n. So in every grouping, if I add my exponents, it's going to give me the exponent. So this is 5. 4 plus 1, 5. 3 plus 2, 5. 2 plus 3, 5. 1 plus 4, 5. 5 by itself is 5. Same thing happens here. Add up the exponents on those terms, and they will give you the exponent that's on your original binomial, okay? These are things that you'll, one, to understand how to break it apart, but two, also just to check your work. All right, then you get what's called a binomial coefficient, and that is the number that's at the front of these products. And they increase and then decrease in a symmetric pattern. So this starts 1 and 1. And then second to last are 5 and 5, 10 and 10. If it's here, 1 and 1, 6 and 6, 5, or 15 and 15 and 20. I'm going to teach you how to find those terms, but they are called binomial coefficients. And that's what it says, the last thing. Those are called binomial coefficients, okay? I'm going to teach you 2 ways to find it. One is with the C, and one is called Pascal's triangle, which I would recommend Pascal's. All right. So the way to find your binomial coefficients, this is one way to do it. And I'm going to tell you right now, I don't even teach this way in AP. I teach the Pascal's, okay? But because you already know your CNR, I'm going to show you both options and you get to choose. Every coefficient, every binomial coefficient as it expands can be found using your CNR. The tricky part is the R. So if it is the third term in, for example, my n is the same no matter what. If it's raised to the 5th power, then the n is 5. But the R is not the number term it is, because this is the first term, this is the second term, that's the third term. It doesn't go that way. You have to start it with 0. So if it's the third term, my R is actually 2. And that's where people get confused. So I will teach you another way to do it. If it confuses you, I don't want you to do it. Okay? I'm going to teach you another way to do it. Okay. This we know how to, I'm going to actually skip this slide because we know how to do this, right? You know how to do CNR? Yes or no? Yes? Like just CNR by itself is n factorial over n minus r factorial. times r factorial, right? We did this with we know how to do this. C is your combination. It's the same. Remember we did this with P and R? And we did it with C and R? It's the same C. Used in a different way, but same. Your calculator has that button. Yes, we know this? Okay, normally we teach this first, which is why it's here, but we already taught it. And this little combination, that 8-0, means C80. Good? Because we did it the other way, right? We did this with combination. It's the same thing, okay? But I'm not going to use this today. Normally I teach this first, and that's why it's there. We are going to teach it this way. So when you write out the coefficients for a binomial that's raised to a power, it's called expanding. To expand, we're going to write all the variables in decreasing degree order for the first term and increasing for the second. And then we're going to find all the coefficients for each term using what's called Pascal's triangle, which I'm going to pull from the end of. This is called Pascal's triangle, okay? And again, it feels like it's a lot in the beginning, but I promise you do this 3 times, one time even, you'll know how to build it, and you will want to be able to build it, and I'll tell you why. This gives you your binomial coefficients, okay? So I'll show you how to build it, and I would practice it. It starts with 1 at the top, always starts at 1 at the top. The second line is a 1 and a 1. And then it always starts with 1, it always ends with 1. So I could literally go all the way down here. I won't because I want to make sure my spacing lines up. But the first one in every line is 1 and the last one in every line is 1. All the numbers in between come from adding the 2 numbers above it. So this is 1, and then if I add 1 and 1, I'd get 2, and I end 1. And then I go to the next row, start with 1. I add 1 and 2, I get 3. I add 2 and 1, I get 3. The last number's 1. I start with 1. I add the 1 and 3, I get 4. I add the 3 and 3, I get 6. I add the 3 and 1, I get 4. I end with 1. I do it again. 1, 5, 10, 10, 5, 1. And I could just keep going. 1, 6, 15, 20, 15, 6, 1. Now these represent your binomial coefficients. So there are 3 parts to every term. The variable raised to the high power, decreasing. The second variable raised to the lowest power, increasing. And the binomial coefficient. So if I am raising a parentheses, whatever n is the first number in my line. That's how I know what line to grab. So if I'm raising something to the 3rd power, I'm going to go to the one that after the 1, because they all start with 1, but that after the 1 starts with 3. Those are going to be, because think it's always 1 more than your term. So if I'm raising something to the 3rd power, there are 4 terms. There should be 4 terms in the line you grab. If I'm raising something to the 5th term, or to the 5th power, I go to the line that starts with 1, then 5. And those are going to be your binomial coefficients. So on your test, I wouldn't just write the Pascal's triangle in the beginning because you want to know what the power is. Like, what if I only say go to the 4th power? You only have to go to that 4th line. Well, 5th line, but the one that starts with 4, okay? But you do need to know how to build Pascal's triangle. And this slide is just showing you those binomial coefficients in the expansion. So the first line is 1, then it's 1, 1, then it's 1, 2, 1, then it's 1, 3, 3, 1, then it's 1, 4, 6, 4, 1. All of those red or pink letters come from Pascal's triangle, okay? Okay, so this says write the expansion of the expression. There are going to be times when it's faster to just multiply it out. Like if it's to the 3rd, it might not be the worst thing either to just multiply it out. But you're not going to get something that's just to the 3rd. So we're going to do it the long way, okay? Long-ish way. So the first thing you want to do is figure out how many terms there should be. How many terms should there be? Nope. 4. 1 more than the exponent. Yes? So I'm going to literally mark my space for 4 terms. Then I'm going to take my first term and I raise it to the highest exponent down to 0. So this is going to be x to the 3rd, x to the 2nd, x to the 1st, x to the 0. Crazy with us. You don't want to miss this. This is so fun. And then you're going to take your next term, and that next term is a -2. The negative stays with it. And we're going to do the opposite order. So you can either start from the end and work your way down, or start from 0 and work your way up.
Does it matter?
Yeah.
So like it has to be that like the x's are going down like from that.
The first term down, second term up. In general, if you would totally give the whole thing, it wouldn't matter, right? Because order doesn't matter. It's commutative. You can move it around. But if it asks for the fourth term in the expansion, now it matters. Does that make sense?
Yeah.
Okay. All right, now we got to add in the binomial coefficient. So if this is 3, that means I'm going to the row that after the 1 starts with 3. There should be 4 terms. And then I throw that 1 in the front. 1, 3, 3, 1. And there is technically a plus sign in between each of these. That plus sign might change depending on the sign when we expand it, but they are all a sum or difference. Now we go through and simplify. So for my first term, 1 to the first, 1 is by itself, times x to the third. What's negative 2 to the 0? 1. So my first term is x to the third. Then I do my next term, 3 times x squared times negative 2 to the first, so negative 2. And then you multiply your constants out. So this would be negative 6x squared. Then I go to the next one. 3 times x to the first times negative 2 squared, which becomes 4. And that's a positive 12x. And then I go to the last one. 1. X to the 0 is 1. Negative 2 to the third is negative 8. Minus 8. This is my expanded binomial. Nope. Nope. You're just expanding it. So fun, right? Let's do a bigger one. 2x minus y to the fourth. So how many terms are going to be? 5. 1, 2, 3, 4, 5. I'm going to take the first term, start at 4, and make it smaller. So 2x to the fourth, 2x to the third, 2x to the second, 2x to the first, and 2x to the 0. I'm going to do the opposite with the y. Start at the 0, work my way up. Y to the 0, y to the first, y to the second, y to the third, y to the fourth. And I'm going to finish it off with the binomial coefficient. I got to go to 4 this time. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. That's the row I grab. So 1, 4, 6, 4, 1. Yep.
Why is it y and not negative y?
Oh, you're so smart. It's a negative y. Thanks, Angel. All right, now we simplify them all out. So I get 1, which stays as 1. 2 to the fourth is 16. Let me do it in a different color. 16. X to the fourth and negative y to the 0 becomes 1. So my first term is 16x to the fourth. Then I get 4 times 2 to the third, which is 8, times x to the third, times the negative y to the first, which means it's negative y. So 4 times 8 is 32. The negative comes down, so negative 32, x to the third, y to the first. Then I go 6 times 4 times x squared times y squared. The negative's going to go away. 24x squared, y squared. Then I go 4 times 2 times x times a negative y to the third. Negative 8x y to the third. And then 1 times 4 y to the fourth. Questions? I would say once you practice it a couple times, you get the hang of it. Here are the mistakes people make with the negative, which I made. Don't do that. 2, they will like somehow multiply these numbers. Don't do that. Or they won't multiply out the constants. Any constant that's part of it has to get multiplied. Okay, those are where silly mistakes get made, so just be careful. Okay, this I am not going to teach you. Okay, I used to teach this method and what I'm about to teach you, and this one gets super confusing. I'm not teaching you that method. I'm going to teach it to you different. Like AP, we taught it the other way, and they were fine. So we're skipping this because people get confused with the R. What we're going to do is go straight here. So this says A plus 2B to the 8th, and I want the 5th term. Okay? So I will literally leave my blanks out till the 5th term, and I won't even touch anything else. So I go 1, 2, 3, 4, 5. There would be other ones here, but I'm not worried about them. Then I look at my exponents. The first one would be raised to the 8, then the 7, then the 6, then the 5, then the 4th, and that's the one I want. And then the other exponent would start at 0, go to 1, go to 2, go to 3, go to 4. So those are the exponents I want. I want this term. You with me so far? So I'm going to raise, I know they're the same, but they're obviously not always going to be the same. I'm going to raise the first term to the 4th. I'm going to raise the second term also to the 4th. And then I have to look for my binomial coefficient. What line would I have to go to this time?
9.
Nope. Well, it is the 9th line, yes. But what am I starting with? How do I know when to stop?
Oh, you have to go.
Now I know to stop, right? The 8th row, well, the one that starts with 8. So 28, 56, and I want the 5th term, so I'm going to go one more, and that 5th term is 70. I kept going. It'll catch up eventually. So I went all the way to the row that started with 1, 8, but I only went to the 5th term. I don't even need to keep going, okay? So that 5th term, which will pop up hopefully eventually, is 1, 8, and it stops at the 5th term, which is 70. So now I also have a 70 here. So it says 70 times A to the 4th. 2 to the 4th is 16 times B. And I would get 16 times 70, which is 1,120 A to the 4th B. I don't know if it's ever going to catch up. So this should have been 1,120 A to the 4th B to the 4th. Yeah.
Why is it times 16 times B?
So this 4 goes to both.
Oh, okay.
That 4 goes to the 2 and that 4 goes to the B.
Okay.
Yeah. And like first, if this was a negative, right, then this would be a negative 2 to the B. It's to the 4th, so it doesn't matter. But if it was the 3rd, now it would be a negative term.
But isn't it, I thought the B and the 2 aren't connected? Like they're separate terms?
No, the B and the 2 are one term, but that whole term is raised to the 4th. So they both get the exponent.
But then how come you multiply the 16 by the 70?
Because this is all one term. Any numbers in here have to get multiplied together. This is a single term. So it's all a product. Good? Yeah? Come on. All right, 6th term of A plus 2B to the 8th. Now I would go 1, 2, 3, 4, 5, 6. My exponents, let's see if we can do it faster. 8, 7, 6, 5, 4, 3. This is the one I want. The other exponent, 0, 1, 2, 3, 4, 5. So I want A to the 5th, 2B, no, sorry, A to the 3rd. A to the 3rd, 2B to the 5th. And then my binomial coefficients, I already built that row. So I'm just going to, all right, I want the 6th term. So I would have gone 1, 8, 28, 56, 70, 56. 1, 2, 3, 4, 5, 6th term. So on the homework, I will tell you, I didn't even, like, because you know how WebAssign will, like, make them big, like, it will give you a number that is different from somebody else. If you have to use a calculator, use a calculator, okay? But when it comes time to the test, they are, I think, manageable. Like I took your test, and they're manageable without a calculator. I did it without the calculator, okay? This is what, 32? B to the 5th, and then we multiply those together. So homework, I will tell you, one, the numbers could get a little bit bigger. You can use a calculator. Also, 56 times 32, 1,792. A to the 3rd, B to the 5th is what you should get. Also, the way it's worded on the homework will say, here's your expansion, like A plus 2B to the 8th, and then it will say find the number of term, but instead of saying 6, it says n equals 6. It means the same thing, okay? But that's how, it doesn't use the word 6. It says n is 6. It's the same kind of process, okay? Questions? All right, so that's where your content for your test stops. Tomorrow review, Monday review, Tuesday ACT, Wednesday test. Yep.
You're gonna be here